Hi, welcome back to another day, another video journal. Today is 16th of April 2024 and today we are going to see our project, my project, DSBDA. It is Room Occupancy Estimation. So I'm going to take you through my projects and the codes and the GUI also. But before that, let us talk about my day. So today was my college again and I again went late for my college. But anyways, I got my attendance today because I had a good relation with the teacher, DSBDA teacher, data science and big data analytics teacher. So yeah, it was a great day. I did assignment on Hadoop. Hadoop is a backend framework in Java, which is used to store and manage file systems. It was a bit complex, but anyways, I did it. It was in Java, but I'm not so familiar with Java. But anyways, I did it. So and next thing is I was working on this project only to make the GUI more interactive. So let's take you on this journey. And again, there's the farewell of our seniors. They are in 4th year and they are going to leave the college, and their college is coming to an end. So they asked us for their farewell. So the official farewell is going to be organized in the next week, but the unofficial farewell is in a dilemma of organizing on the 20th of April or in the May after our exams. So yeah, let's see what happens, and I'll definitely let you know what the decision is. Now coming back to the project, so let me quickly give you an overview of the project. So the project was about room occupancy estimation, and we have been given a data set in which there were 19 attributes including date, time, 4 types of temperature, 4 types of light, 4 types of sound, CO2, slope CO2, PIR values, and the second PIR value. So according to these data, we had to estimate how many people can be occupant in a room at a particular time. So suppose today is 16th of April and in the morning the temperature is around 28 degrees Celsius. In the afternoon it is around 32 degrees Celsius. In the evening it is around 27 degrees Celsius, and in the night it is around 26 degrees Celsius. Also, depending on the light conditions, light is measured in luminance. So the luminance intensity of the light is measured. Suppose in the morning it is 121, in the afternoon it is 200, in the evening it is 93, and in the night it is 52. So these are the lighting conditions. And the CO2 values. CO2 values are how is the CO2 incoming and outgoing CO2, the breathing intake. These all data are based from a sensor. So the room was continuously on a watch of a sensor. It was continuously keep tracking of these records and sending us the data. So according to these data, we had to estimate how many occupants can be there in a particular time of the day. Suppose, as I have told you the temperature example, suppose there were 2 people at that time according to the training data set. So now we'll find, suppose we'll give random values of the temperature and lighting conditions and see how many people can be there at that particular time. This project is based on a machine learning model. We had done the classification, and we have done 3 types of classification: random forest, decision tree, and SVM. SVM is support vector machine. I'll let you know about these classification in some other video, but let us go through the code right now. So here we have our code. We'll first import Flask. Flask is a framework of Python to make a web page, and then we'll import the pandas. Pandas library is used to make our data reading and writing. Then we'll import sklearn. Sklearn is Skygate learn. It is a library in Python used to make machine learning models, and we'll import train and test split. And then random forest classifier. The 3 types of classification we have talked about: SVC, support vector, and decision tree. And we'll also import the accuracy score and also the matplot to plot the graphs. Then we'll declare the app and read the data set, which is occupancy estimation. Let me quickly open the occupancy estimation data set. So this is the data set which we have with us. We have the date, time, S1 temperature, S2 temperature, S3 temperature, S4, S1 light, S2 light, S3 light, S4 light, S1 sound, S2 sound, S3 sound, S4 sound, and then CO2 slope, and PIR, and the room occupancy count. Let's take the first data set. It is of the 22nd of December 2017 at 10:49 a.m. So the temperature 1 was 24.94, temperature 2 was 24.75, temperature 3 was 24.56, and temperature 4 was 25.38. And similarly, all the lighting conditions value are also given along with the sound and CO2. So according to these values, we got the value 1. So according to these all values, we got the data 1. So at that particular time, with that particular temperature and sound and light conditions, only one person was there in the room. Now coming back to the main file, we'll drop the date and time as we'll not need it right in this dataset to perform our applications, and then we'll take average data of the room occupancy count. Suppose the room occupancy count was 1, 2, 3, 0. So we'll take all the values from all the 10,135 values, and we'll take the average. Okay, and then we'll plot a figure of the data set and the average values of temperature, light, and sound according to the room occupancy count. So we have plotted the data set, the S1 temperature average, S1 light average, and S1 sound average, and we'll plot it against the room occupancy count, all their average values against the average value of room occupancy count. Okay, so this is it. And when we'll drop the room occupancy count from X and Y to train and test our data set, and then we'll split the training and testing data set in the form of 20% to 80%, 20% for training and 80% for testing. Okay, so we have imported the classifiers random forest, SVC, and decision tree, and then we'll train them accordingly, the X train, Y train, and we'll make the predictions. So in machine learning, it is very necessary to train a data set and to predict. So we'll be testing a data set on certain values, and then we'll be putting values from our side to see the predicted values. Okay, so now we'll make the calculations. So here we have taken the request form. So we have made a form, and then we had requested all the values, all the attributes, temperature, light, sound, CO2, and PIR. So after taking all these values, we'll be putting it in the classifiers and predicting the given values, and then we'll return the all the values and the predicted outcome. So here's the index file. We have the doc type HTML, room occupancy count, and we have styled a little bit. And here is the form which is used to collect all the input values of the attributes, the S1 temp, S2 temp, and so on. So after the form, we'll make a if condition. If the prediction is not none, predicted room occupancy count is the prediction which is given from the app.py file. So let's run this code very quickly and see the output. I'll type the python app.py, and we'll get a local host link which will be opening in a bit. Come on. Yeah, we have the link here which will be opening, and it's taking a bit of time to load. So yeah, this is the room occupancy prediction. So we'll give the values accordingly. So S1 temp, let's suppose I'm giving 27. Okay, S2 temp I'm giving 28. S3 temp I'm giving 29, and S4 temp I'm giving 24. S1 light condition, in the luminous values I'm giving 100, S2 as 178, S3 as 134, S4 as 56. Okay, S1 sound as 0.76, S2 sound as 0.54, S3 sound as 0.43, and S4 sound as 0.98. And CO2 values will be giving 555. CO2 slope values will be giving 1.8765, will be giving a random value, and PIR values will be 1 and 1. So let's predict the outcome. So here is the outcome. So the predicted room occupancy count, which is this, according to random forest, is 2, SVM is 2 and decision tree is 2. We can predict also various different data sets in this, and here is the average graph which we have plotted in the code. So this is the average values of temperature, light, sound and room occupancy count. So the orange one is of light, this one, orange one is of light, the blue one is of temperature and the green one is of sound. So they are plotted against the room occupancy count average. So you can see it here. Also, let me take you to the GitHub code of the same GitHub and my repositories. The net is a bit slow, no worries. So yeah, this is the repository and I'll be attaching this link in the description box so you can see it from there. This is our group. This is me, this is Nishant, and this is Shruti Sinde. They are my classmates and friends, very good friends. So I have tried to deploy this project, but it is not working at the moment, but I'll definitely work on that and try to redeploy it again, and let's see what happens. So yeah, that was it, and I hope you liked the explanation, and this is my first time explaining in this in a particular video, and I'll try to improve some things after watching this which I need to do in the same. And so yeah, do let me know what you have think about this project in the comment section, and thank you for being here. Have a great day. Bye bye.